Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey.
Hi everyone, so we're still on measures of variability, and the next measure of variability that we're going to discuss is what we call the variance. Okay, variance is like a magnified version of mean absolute deviation. In this case, we magnify our data to take a closer look. This is how we get the variance for population and the variance for sample. The only difference is the denominator. In the sample, we have n minus 1. We are still going to work on the two data that we had in the previous video. So, in order for us to find the population variance, we need to get the square of the difference of the score and the mean. But we need to get the summation. So, let's start working on group 1. The first thing that we have to do is to subtract. That would be 60 minus 81 squared. So that's negative 21. Squaring that, we have 441. 70 minus 81. So you have to get ready with your calculator. That would be negative 11 squared. Here. And the answer is 121. 80 minus 81 is negative 1. Square that would be 1. 95 minus 81, the answer is 14. Squared will give us 196. Next, we have 100 minus 81, that would be 19. Squaring 19, we have 361. So since we have all these values, for us to be able to use the formula for the variance, again, let's use sample in this case. The variance is equal to the summation of the square of the score and the difference divided by, since it's sample that we are using, n minus 1. Therefore, we need to add everything to get the summation. That would be 441 plus 121 plus 1 plus 196 plus 361, and the answer is 1120. So that means to get the variance, we need to get 1120 divided by, since these are 5 values, minus 1 would give us 4. 1120 divided by 4 would be 280. Therefore, the variance is 280. Okay, that would be the first group. Now, let's look at the second group. In the second group, we do the same. 79 minus 81, that would be negative 2. Squaring that, we have 4. 80 minus 81 would be negative 1. Squaring that, we have 1. 81 minus 81, 0. So, it's 0. 82 minus 81 is 1. Square is 1. And then 83 minus 81 is 2, square is 4. If we add all these values, we have 10. Therefore, the variance is equal to the summation of the score minus the mean squared over n minus 1. Again, n is 5, minus 1 would be 4. So that would be 10 over 4 equals 2.5. So the variance in this case is 2.5. What does the variance actually tell us? This is far too small and this is far too big, no? If we're going to look at it, because as what I've mentioned earlier, from the deviation, we take a closer look with our data. It's like before we have a bird's eye view of our data, now we have a closer view of our data, a more detailed view of our data. The variance actually tells us that if we have a higher variance, there will be more variability in the group's performance. Okay. It also tells us that when the variance is high, the more heterogeneous is the group's ability. just like the one in the mean absolute deviation. Remember, it's also a deviation, but it's the square deviation. So the variance is the square deviation, the average of the square deviation. So that's why it actually tests the same thing, no? Another thing is that what if we have a lower variance? Then there will be less variability in the group's performance. At the same time, the more homogeneous will be the group's ability. That's what we want to say when we talk about variance. Therefore, in the previous item that we looked into, when we look at the two performances, the two data that we have here, first we can say that group 1 showed more variability in performance than in group 2. We can also say that group 2 is more homogeneous than group 1 in terms of the ability in statistics. I'll just put it here. Ability in statistics. Okay, those are the two conclusions or the two interpretations that we can have when we have the variance. Okay, but we're not yet done. So this is how we do it in variance. So we're done with the variance. This time, let's go to standard deviation. In standard deviation, it is said to be the square root of the variance. We are looking at how the values deviate from one unit to the other. That's how deviation is. When we talk about standard, it is the same for all. That's the standard. That's what we mean by getting the square root of the variance. Notice that the formula inside the radical sign is actually the formula for the variance. This is for population and this is for sample. Since we started with sample, we're going to find the standard deviation of the sample. Let's take the two groups data, group 1 and group 2. We're not going to go through the same process because we already have it. But what we do know is that the standard deviation is equal to the square root of the variance, same as with the other group. So we're going to write this and this in our data. Therefore, to get the standard deviation, we have, what's the value again? 1,120 divided by 4. 1,120 divided by 4. On the other side, what do we have? 10 over 4. Okay, let's have 10 over 4. What will be the standard deviation here and what will be the standard deviation on the other side? In group 2, the standard deviation would be square root of 10 over 4. So we have the square root, then we click in the fraction. That would be 10, square root of 10 over 2. But we click on SE to make it decimal. 2 decimal places, that would be 1.58. How about on group 1? In group 1, the standard deviation would be square root again, then the fraction 1,120 and minus 1. Remember, we have 5 samples, so 5 minus 1 is 4. 4, and the answer is 2 square root of 70, we click on SC, that would be 16.73. It means that the score in group 1 deviates by 16.73 units. So that would be really farther from the range compared here that the standard deviation or the deviation from one unit to the other would be 1.58. Therefore, in the standard deviation, we can say that the higher the standard deviation, the more scattered or spread out is the data. We can also say that it's farther from the mean, the more it is farther from the mean. So, we can conclude here that group 1, the data or the scores of group 1 are more spread out than the scores of group 2. We can also say that the scores of group 2 are closer to the mean compared to the scores of group 1. So, that's what the standard deviation is all about, on how spread out or how closer to each other in the data, just like the range. But we're not yet done. We still have one more, which is the coefficient of variation. One more computation to make. In the coefficient of variation, let's take the first one, the group 1 and group 2. What does it measure actually? So coefficient of variation is simply the ratio of the standard deviation and the mean. It is used to compare variability of two or more sets of data, just like the variance. In order for us to compute for the coefficient of variation for each group, we need the standard deviation and the mean. For group 1, let's go back. The standard deviation is 16.73 and the mean, what's our mean again? For group 1, 81. The mean are the same for both. Remember, 81 and 81. Okay, so it differs with standard deviation. The standard deviation of group 1 is 16.73. So that would be 16.73 over 81. And the standard deviation of group 2 is 1.58. So that would be 1.58 over 81. Let's use our calculator for computation. That means 16.73 divided by 81 is equal to approximately 0.2065. On the other side, we have 1.58 divided by 81. And the answer is 0.0195. Meaning, if you have a lower coefficient of variation, it means it has lesser variability. And the higher coefficient of variation, then you have more variability in terms of performance. So, these are the measures of variability. Hope you learned something relevant for this day.
This had been a great learning adventure. So, see you next time on another Math Venture with Teacher Rev. Remember, don't stop until you're proud. Learning math takes time. Bye!